Okay, 2007. Says in the circuit below, the reading of the voltmeter is 2.4 volts. Let's add that to your diagram. What is the voltage across Y? It is advised you show clearly how you get your answer. Our rule for voltages is, in any one loop, the sum of the voltages across each of the components must add up to the supply voltage. So it has to add up to give 3 volts. So this must be 0.6 volts. The current through X is 0.2 amps. What is the resistance of X? Well, we can do V equals IR. The voltage across X, we were told, is 2.4, is equal to 0.2 R. 2.4 divided by 0.2 equals R, which is 12 ohms. Why is the current flowing in resistor X equal to the current flowing at resistor Y? Well, whatever flows through here, it has nowhere else to go. There's no junctions there. So like if 10 cars or 24 cars drove through here, 24 cars would have to drive through there. Or sorry, what current did we say? 12. So if 12 cars drive through here, then 12 cars must also drive through there. So really what we're saying there is Y is in series with X. Okay, there's nowhere else for the current to go. There's no junction. They're one after the other, so whatever flows through X must flow through Y. Third resistor is placed in parallel with X and Y as shown. The current through Z is 0.3 and the current through X is unchanged. What is the new current supplied by the battery? Well, if we look at this junction here, 0.3 goes this way, 0.2 goes that way, add them together, it must be 0.5 amps went into that junction. It says to show clearly how we get our answer, so let's do that. But it's not very complicated, we don't need all that space. What is the voltage across Z? Well, if we take this path around the circuit, the sum of the voltages has to add up to give the supply. That's 3, which means then there must be 3 volts across Z, because it's the only component on that lower path. Calculate the values of the resistances of Y and Z. You're advised to show clearly how you get your answer. Now, we can go up here to work out what Y is, because we know that the current is 0.2 amps. That's 6 volts, so we can do V equals IR, and we had that this is 0.6 is equal to 0.2 times R. 0.6 divided by 0.2 equals R, which is 3 ohms. Okay. The resistance of Z, then we do V equals IR for it. So V is 3 equals I, which is 0.3 times R. 3 divided by 0.3 equals R, which is 10. So Z is 10 ohms. Calculate the combined resistance of X, Y, and Z. Well, X plus Y, we just do the X was 12 plus the 3 from Y, which is 15 ohms. And then they would be in series with the 10 ohms from Z. Okay, so this is X and Y combined together. They're in parallel, so we need to do RT equals 1 over R1 plus 1 over R2, and 1 over RT equals 1 over 15 plus 1 over 10, which will be what, 25 over 150. Just check that. And it gives us 1 over 6. So we have to remember to turn that back around to give us 6 ohms. Okay. Be careful there. You will get ECF on this question. So let's say you weren't able to get those answers. Write something in, and if you work them out correctly from those wrong values you put in there, you could still get 3 marks for that last part. Don't hinder yourselves by not answering the previous part and then not being able to even access the marks in the next questions. Make sure if you couldn't do that, you continue on with the question.